is formed whenever a factor appears in both the numerator and denominator. If I gave you x squared plus 9 over x plus 3, we can reduce this. X squared minus 9 factors into x plus 3, x minus 3. And we have x plus 3 on the bottom. What happens here? That those cancel and we have x minus 3. But we talked about at the beginning, these aren't truly the same thing because they have different domains, right? When something cancels out like this, it creates a hole in the graph. And you have to be able to give me the ordered pair where that happens. So to find x, we just look at what canceled, x plus 3. So what's the 0 of that? Not positive 3, but negative 3. If you set x plus 3 equal to 0, you get negative 3. That's the x value. To get the y, you plug that into the remaining. So my final equation is x minus 3. If I put a negative 3 in there, negative 3 minus 3 is? So negative 3, negative 6 is a hole on my graph. That means it is an open circle. Okay, the rest of it you would just graph like normal. X minus 3, that's just a line. Y-intercept negative 3, slope 1. But this is a point on that line. Even if you are using a graphing calculator, it actually doesn't show you those holes because it reduces before it turns around and graphs it. So you have to find these by hand, and you guys don't have a choice because you don't get the graphing calculator on your test sheet anyway. But this is where they come from, when something cancels out from the numerator and denominator. Any questions there? So we are going to spend the rest of our day graphing these things, and we will do as many as we need for you guys to feel like we are confident. So I have a handout for you guys that we are going to be doing all of our graphs on. You know there's no ways you need that information. All right. So at the top, I have put all the different things that we have to do to sketch these. First thing is we are going to factor our fractions and put them in lowest terms. See if anything cancels out. Because if it does cancel, what have we created? A hole in our graph. So we'll have to check that first. Then we're going to find the x and y intercepts on our graph. We'll do all of our asymptotes, vertical, horizontal, and oblique, and then we will graph it from there. Just like with graphing polynomials, I told you on test or quiz it would be like an A, B, C, D thing, so you don't have to necessarily remember the steps. I'll prompt you. I'll say, okay, part A, factor this and reduce. Part B, tell me the x-intercepts. So I'll tell you, but you have to know how to find all of those things. So if I'm looking at this one, okay, the top x minus 1, that doesn't really factor. X squared minus 4, the x plus 2, x minus 2. Does anything cancel? No. So then we look, sorry, I'm looking at what order I put the steps in so I can do them the same. X-intercepts. Okay, we did intercepts with lines. How do we find an x-intercept? It's when your y is equal to 0. R of x is like my y. It does not matter if you use the original original or your factored one. Either one's going to give you the same thing. If I just went with my original, sorry, and we said we're going to replace our y with a 0. What would you do now? Well, if you're trying to get rid of the fraction, you would multiply by x squared minus 4. What's 0 times anything? So I get 0 equals x minus 1, so what's my x-intercept? 1. Is there a faster way I could have found that x-intercept? Which part of my fraction did it come from? The numerator. An x-intercept is just when the numerator is 0. So if you remember that, you can just look at it, and couldn't we tell 1 makes the top 0? You can just write down 1. If you don't realize it, you can always do the process we just did. X-intercept, our y is 0. So we solve. Our y-intercept, what is that? It's when x is 0. So again, doesn't matter if you do it in the original or the factored one. I get -1 over -4, which is 1/4. Okay, I can plot those on my graph as I go. I hit my x-axis at 1, my y-axis at 1/4. Alright, then we do all of our asymptotes. So vertical asymptotes. This is also another benefit of factoring. It's x equals what makes the bottom 0. So what makes x plus 2 equal to 0? -2. And what makes x minus 2 equal 0? 2. So we have two vertical asymptotes. We draw those as dashed lines. We have a dashed line at +2 and -2. Okay, now we have to decide if it's horizontal or oblique. So this is kind of from last week. If you think about the top, we have x to the first, the bottom is x squared. I told you a hint for thinking about it is if you were to divide. Can you do x divided by x squared? So what's that turn into? 0. So horizontal y equals 0. If the top degree is smaller, it's an automatic 0. We can't divide them. So y equals 0, that's my x-axis, that's a y-intercept. Or sorry, my horizontal asymptote. It's okay that I have a point on there. You can never cross a vertical asymptote, but sometimes our graph will cross a horizontal. All right. From here, this is maybe the downside of not having a calculator. We have to do a little more like picking points and kind of checking to see where they are. Asymptotes are lines that our graph's getting close to. So we have two options. This section of the graph, it's got to get close to both of these. So it can look like this, or it can look like this. Do I know for sure which one? No. So how could I figure it out? Yeah. And we don't really even have to write it down unless you really want to. You can plug in. So it has to be something smaller than -2, right? If I'm going to put it in here. So if I put in a -3. Okay, -3 minus 1 is -4. -3 squared is 9. Minus 4 is 5. So when I have -3, my point is -4/5. That's enough for me to see that this part of my curve is above or below that horizontal asymptote. Below, because I'm getting out something below. So we just picked an x value, plugged it in. I know this is the point on my graph, and that's enough then. I know as I get close to these, it's still a curve, but it is just getting closer and closer to those lines. Now my graph has to exist on every side of the asymptotes. Okay, so I have that one. This one's going to come in 3 sections. I have to have something in the left, something in the middle, and something to the right. So now I need to look at the middle. Now we kind of know a little bit already, don't we? We know 2 points. If you want to get a better idea, you can plug in some. You have a calculator in front of you. Is it a big deal to plug numbers in? No. It just takes a couple seconds of typing. So if you wanted to put in -1, right? If I put in -1, I get a -2 over 1 minus 4 is -3. So -1 gives me a positive 2/3. Can you tell what this section of the graph is doing? Yeah, we know it's got to be getting closer to those vertical asymptotes, right? So what it's doing, this section's coming up, this one's going down and hitting my x-axis right there. Okay, in the middle, if you have 3 pieces, that middle piece is probably going to cross over your horizontal asymptote. If you weren't sure, could you plug in more points? Absolutely. Does everyone understand where I'm getting my numbers when I plug in points? Okay, so what are the 2 options for my third piece? It's either above or below, right? So give me a number I could plug in to figure that out. Positive 3. So 3 minus 1 is 2. 3 squared is 9. Minus 4 is 5. So when I put in 3, I get out 2/5. So that section is, yep, it is going to get closer to my horizontal asymptote. So the horizontal asymptote is, as time goes on, we get close to it. So the ends are approaching, the middle may cross through. For homework, could you use a graphing calculator or Desmos to double check yourself? Absolutely. Okay, I encourage you to do that. Make sure if you're putting it in the graphing calculator, you do parentheses around both top and bottom, otherwise you will get the wrong answer. But we need to understand where all these things come from without that calculator too. Is that one okay? This is all we're doing. We're just going to keep doing these problems until we've got it. So let's look at another one. Factoring. What can I do to the top? All right. X-intercept. It's when this whole thing is equal to 0, or really just when what is 0? Yeah. X-intercepts are really just when the top of your fraction is 0. When is that going to be? One positive 1. So I hit my x-axis twice. One positive 1. Y-intercept. How do we get those? 0 for our x's. Does it matter if I use the original or the factor? Not at all. So I get 0 squared minus 1 over 0. Can you divide by 0? No. So that means there is none. We do not cross that y-axis. Vertical asymptote. The vertical comes from the denominator. What makes the denominator 0? 0. This is a line, so I want the equation vertical is x equals. That's why we didn't have a y-intercept, because the y-axis is a vertical asymptote. We are not crossing that line. Okay, now we have to decide if it's horizontal or oblique. So we talked about, think about if you divide it. Can you do x squared divided by x? Yes. What's this one going to be? You multiply x times x is x squared. Then what do we do with that? Subtract it. Those cancel, and all we have is a -1. Can you do -1 divided by x? No. Remember, we ignore the remainder. Is this horizontal or oblique? Oblique. If it's got an x in it, it's oblique. The line is just y equals x. So that's a line y-intercept at 0, slope of 1. So we were graphing that line, y equals mx plus b. There's nothing added on the end, so we started at 0, up 1 over 1. Questions so far? one on each side of the vertical asymptote. The vertical split it in half, so we have one to the left and one to the right. We know it goes through these points, and it has to be getting closer to our asymptotes as time goes on, right? So this one, to the left, should be getting closer to my vertical and closer to my oblique. Oh, that's kind of hard to draw. So it looks something like this. Over here, getting closer to my vertical, closer to my oblique. Try to keep them curved as much as possible. I know it's hard, especially when with those oblique asymptotes, it's a little harder to curve them. It should be clear that your graph is getting closer to the asymptotes. So try to avoid, like sometimes I'll have people that draw something and then it turns away like this. Is that what's happening? No, it's going to keep getting closer. Okay, also remember these are curves, so I shouldn't see like zigzags or corners or anything like that. And at the end, quick check, it should be a function. It should pass the vertical line test. And this one does. All right. If you weren't sure about that, could you plug in some test points and check it? Absolutely. Could you, on homework, double check yourself with a graphing tool? Absolutely. Okay, those things are available to you. All right. Another one? Okay, I want you guys to take a second and see if you can list out the information. This one's already factored for you. So I want you to tell me x-intercept, y-intercept, vertical asymptote, horizontal or oblique asymptote. What is the x-intercept? -1. And where did you look to find that? The numerator. So we hit the x-axis at -1. What's the y-intercept? None. If you put in 0 for all of your x's, you get 1 over 0, which can't happen, so there is none. What's your vertical asymptote? And we have 2 of them. So how many pieces will this graph have? 3, because you have to have something on every side of the vertical asymptote. So we'll have something to the left of -4, something in between the 2, and something to the right of 0. Okay, horizontal or oblique? Horizontal, what's it going to be? 0. Yep. If you think about it, this is an x on top. On the bottom, if you multiply them out, is x squared. Can you do x divided by x squared? Doesn't work out, so it's a y equals 0. Is it a problem that I have a point on that? No, I told you a lot of times, if you have 3 pieces, the middle piece is going to cross your horizontal. It's just the left and right that won't. Okay, so now for figuring these out, I'm going to have to try some points, aren't I? So if I want to know to the left of -4, if I want to decide I could either be above my horizontal or below, so what should I do? Plug in. So if I put in -5, get -4 over -5 times -1, so -4/5. So -5 gives me -4/5. So now I can see this section is below. It has to be getting closer to my horizontal and closer to my vertical. So it's going to look something like that. In between, we're probably going to need some points, aren't we? So if I put in maybe like, what do you think, -2? That would give me -1 over -2 times 2. So we get a positive 1/4. So -2, 1/4. So I know this part is going up. So this is going to be coming down. And this last piece, I need something bigger than 0. So if I put in a 1, 1 plus 1 is 2. 2 times 6, so I get 1/6. So 1, 1/6. Not a nice point, but enough for me to see this is above my horizontal.
You put 1 on the top and then you put 2 on the bottom.
Oh, yes I did. About 1/3. Oh, I put 2 in for both of them on the bottom, didn't I? Okay, let me fix that. If I actually plug in the 1 like I said. So we get 2 for this. Alright, again, those points are to help you decide where your graph is. I'm not necessarily checking that those points are in the perfect spot. When I grade this, I'm looking, did you find the correct asymptotes and graph them? Did you find the x and y intercept and graph it? Did you draw your curve in the right spot, and is it actually approaching your asymptote? Right, those are the things that I'm looking at. Questions on this one? Okay. How are we doing on these? I feel like we need to do at least one more. Let's do, I might skip this one for today. I want to go to this one. If I want to factor, what am I going to have to do on the top? Okay, so that would be x minus 4, x minus 1. Divide by 2. X minus 2. 2x minus 1. X squared minus 4 would break into x plus 2, x minus 2. What happens? X plus, or the x minus 2's cancel. So all of my intercepts, asymptotes, it's going to be based off this one. But when something cancels, I don't just ignore it. That means there is a hole, and I have to know where. So you're giving me an ordered pair. So to find the x value of that ordered pair, we look at the thing that canceled. What makes x minus 2 equal 0? 2. How do we find the y? I put 2 into what's left. So if I put in a 2 there, we get 4 minus 1 over 2 plus 2. So we get 3/4. So on my graph, positive 2 3/4 is an open circle. Now I'm just using this reduced one. So x-intercept, what would it be? What makes the top 0? 1/2. So I hit my x-axis at 1/2. Y-intercept, if you plug in 0 for all of your x's, you get -1 over 2, so -1/2. Vertical asymptote, what makes the bottom 0? -2. So there's only one, that means there's 2 pieces to my graph, to the left and to the right. And now we decide horizontal or oblique. If you try to divide this, can you do 2x divided by x? Yep, what do we get? 2. It's just a number, so this is a horizontal, y equals 2. Alright, we know there's 2 sections to the graph. One of them I can tell right now. This piece is going to come down. Make sure when you draw on that line you don't accidentally fill in the hole. That circle is open. I just need to figure out if this other one is above or below my horizontal asymptote. So I could plug in a number. Again, you can do it into reduced one. If I put in -3, for instance, I'll get -7 over -1 or 7/3. So -3, 7/3, that's bigger than 2, so it's up here. And it will look something like that. Questions? So I am going to give you a handout. We've practiced some of these, not a ton. I know they are more time consuming. So why don't you guys do the front only on this? So 1 through 4. 4 whole questions for your homework. There we go. All better.
Really confused, like where that
No,
7/3.
it's one of my days where I say one thing and write a different. So I've been doing that all day. I apologize.